So this video is a snapshot of an ongoing investigation into how to use Revit to extract overall building weight, looking at weight as a fundamental kind of building information and seeing how to use the software in a way that gets us to that number and how easy or difficult it is to get there. So there's a test that's set up with different wall systems, some steel, some concrete, and the walls are all built a little bit differently. You'll see that this first one is actually built with studs as separate elements and then the wall layered on top of that. This one, there's a layer that represents the studs and then brick and insulation on top of that. Here's CMU, here's glass and aluminum curtain wall. We've got steel, we've got concrete. And the way that we're going to do this is primarily to do it volumetrically. And we'll do that by going to a schedule and a material takeoff. And we want to do this as multi-category so that it captures all the information. And we'll bring over family and type, material area for reference, material name so that it captures all the different layers of the wall system, and material volume. And then we'll move area down. So what you'll see is that the wall system is shown here, and then next to it under material name are all the different layers of the system. The area should be identical, whereas the volume is going to be different depending on the thickness of each material. We've got the studs when they're built separately, but then in the wall where the studs are part of it, you'll see here it's actually giving us the total volume for that layer, not for the actual amount of the studs, so there would have to be a further calculation to figure that out. We have glass, we have the steel, we have the concrete. Now what we want to do is we want to create a parameter so that we can input the weight for each material and then use that to calculate with the volume to find a total item weight. Now one way to do that would be to go to Fields, Add Parameter, but that's actually going to be a little bit too limited and it's not going to get us the kind of parameter that we need. So if we go to Manage, Project Parameters, Add, and then here we want to make sure that it's on instance, and we'll call this pounds per cubic foot. Let's make it a number parameter, and we want to go down to materials, and that materials doesn't show up when you do it through the other window, but it does if you come through the manage window. So we hit OK. And then we'll bring that over. And then what we want to do is we want to do a calculated value where we multiply volume times pounds per cubic foot. So calculated value, we'll call it item weight. The formula would be volume times pounds per cubic foot. You're going to get this error message. You have to divide by 1. That'll allow it to go through. So now we need to have the information for pounds per cubic foot. And if you have something, a table like this, that's going to get you a lot of that information. Others can be looked up online or wherever else. So let's say that we were looking at Western red cedar. That's about 22 pounds per cubic foot. It's going to run the calculation to give us the item weight of cedar. Gypsum is going to be about 32 pounds per cubic foot. And then even though it's an instance parameter, you'll notice that it actually assigns it to all the instances of gypsum on the project. The rock wool insulation is about 2.8. The steel studs, so steel is about 490, and that's going to run it for all of those. But it's not going to do it down here for this, so we have to do that separately. 90. Glass is about 156. So you're starting to build up the total weight that way. This one you'd have to do a separate calculation to really figure out what the pounds per cubic foot of a stud wall is, maybe spaced every 16 inches on center. But as this is all building up, you can go back into here, calculate your grand totals, and you'll start to see the total weight as that gets built up. One thing that you'll notice is that even though it's capturing all of these elements, it didn't have the mullions. For some reason those don't come in this kind of a takeoff, so what we have to do is a separate schedule by going into View, Schedules, Schedule and Quantities, and then go down to Curtain Wall Mullions, Mullion Schedule. And here we'll take family and type and length. So what that's giving us is the mullion and the length of each mullion. So here we have to come up with a weight per linear foot. So we'll do, this time we'll add the parameter this way. It should work just fine. Call it pounds per linear foot. And in this case we want to do it as a type. So that way it assigns it to each of those rather than have to fill in each instance. We'll do it as a number, and then do a calculated value. Call it item weight again. Length times pounds per linear foot. Divide by 1 again. And then in order to figure out that weight per linear foot, I did a rough estimate just by building up a section, giving it a 1 foot length, analyzing the volume, multiplying that volume times the weight of aluminum, and coming up with about 2.3 pounds per linear foot. So it's going to assign it to all of those volumes and then give me the item weight for each. We can go into here, get the grand totals, and then calculate the totals. And so we get the number there. We're starting to build up our totals here, and that's the way to go about it.